With this Hughes Views, I'm going to talk a little bit more about the scientific method. So in science, there's a process by which we answer questions, and usually those questions get answered when at first you either make an observation or you're just generally curious about something. So maybe if we're thinking about this, the COVID pandemic, you can think about wearing a face mask. All right, so do face masks stop aerosols from passing through? So you could make a hypothesis or a prediction like, yes, face masks do work, or no, face masks are inadequate at stopping aerosols from passing. But then what you'll have to do is you'll have to come up with some type of experiment to test your prediction or your hypothesis on on face masks, for example. So maybe you want to use like a spray paint can and a mask and pretend like the spray paint is, those aerosolized particles, and see if spray paint makes it to the other side of the mask, right? That would be an elementary type experiment you could run to see whether or not face masks are blocking aerosols from reaching the other side. And then you either, if your results of the experiment concur with your prediction or are consistent with, then that kind of contributes to the larger body of science. But then let's say somebody else in the class did a different test and showed that when they used a spray bottle for their experiment, that the water leaked towards the other side, or they were able to see it from the other side. So maybe that negated yours. So we need further testing, right? We're still unsure then. One person's experiment showing it's working, the other person's showing it's not. So, honestly, in science, scientists come together and work collaboratively to come up with experiments that, are better than using a spray can or a squirt gun. So we continually have ideas and we test them, and we're right and we're wrong, and we're really wrong most of the time. And honestly, half the time the experiments don't work the first time we run it. So, it's just this cycle here of, performing the experiments and collecting the data. But eventually it gets to a point where you do have some tangible evidence to support your claim or your hypothesis to begin with, and that contributes to a large body of knowledge. Usually, if other scientists start to show the similar results, your hypothesis will become a theory, and only after much additional testing and constant observation could that theory be turned into a law. So we don't have that many laws. We think about maybe the law of conservation of mass, but that's because it's been proven uniformly for hundreds of years. But most things are theories, kind of like Darwin's theory of evolution. No, that's not a law of evolution, but it's a theory, even though there's a lot of experiments out there that kind of show, or there's just a lot of evidence to help show that this evolution is how, life has come to be how it is today. It's not necessarily a law just yet.